All right, let's dive into something straight out of a sci-fi movie. We're going to explore a world built from materials that seem to just defy the very laws of physics as we know them.
I mean, seriously, what if you could wear a jacket that's insulated with, like, a piece of a cloud? Or have a phone screen that's way stronger than steel, but you can fold it up like paper? And yeah, what about a real-life invisibility cloak? Well, this stuff isn't just fantasy anymore. Scientists are basically becoming master architects, but on an atomic level, and they're building the impossible.
So, what's the secret? Is it some kind of magic, a new element from a meteorite? Nope, it's actually much more clever than that. The secret is architecture. It's not about what things are made of, it's about how they're put together.
So let's talk about that secret ingredient. The key to unlocking all these material superpowers, it all lies in how you arrange the atoms on a microscopic, invisible level.
The official term for these things is advanced materials. And the name says it all. These aren't materials you just, dig out of the ground. They are meticulously designed and engineered by scientists to solve very specific problems. They are built, not found.
Okay, think about it like this. Imagine you have a bunch of Legos. You can take those same exact bricks and build a flimsy, simple wall that falls right over. Or you could use those same bricks to build a strong interlocking tower. The arrangement changes everything, right? Well, it's the exact same idea with atoms. You arrange carbon atoms in messy stacks, and you get graphite, the soft stuff in your pencil. But arrange those exact same carbon atoms in a perfect, flat honeycomb pattern, and you get graphene, one of the strongest materials ever discovered.
And that brings us perfectly to our first superstar material, graphene. This stuff isn't just strong, it's a material that has a list of properties that are almost, unbelievable.
And get this, the story of how it was discovered is just incredible. It didn't take some billion-dollar super collider. No. The breakthrough came from a pencil and a regular roll of sticky tape.
So back in 2004, you've got these two scientists, Andrei Game and Kostya Novoselov, and they're literally just messing around, peeling layers off a piece of graphite with Scotch tape. They kept peeling, and then they realized the thinnest, most valuable layers were actually on the pieces of tape they were throwing away. It was just a little bit of playful curiosity that ended up winning them the Nobel Prize. Amazing.
So what exactly did they uncover on that piece of tape? Well, a material with a whole catalog of superpowers. We're talking 200 times stronger than steel, but at the same time, it's 5 times lighter than aluminum. It conducts electricity even better than copper, and it's so ridiculously thin that it's almost completely transparent. Oh, and you can stretch it like rubber.
And just look at this comparison. It really puts things into perspective. You stack it up against the classic materials we build our world with, steel, aluminum, copper, and graphene just crushes it in almost every single category. It's stronger, lighter, a better conductor, and you can see right through it. It's just wild.
All right, so we've seen the unbreakable. Now let's get to the unbelievable. Our next material looks like someone figured out how to capture a piece of the sky. It's called aerogel, but you might know it by its cooler nicknames, like frozen smoke or solid cloud.
Now here's the part that's going to blow your mind. What's aerogel made of? Mostly nothing. Some versions of it are up to 99.8% air. It's basically the ghost of a solid. It's this delicate, empty framework that gets left behind after all the liquid has been super carefully removed.
And because it's mostly empty space, you get this material that's just full of wild contradictions. It looks like a hologram, but if you touch it, it feels kind of like hard styrofoam. It's strong enough to support thousands of times its own weight, but hit it too hard and it'll shatter like glass. And its most famous superpower, it is one of the best insulators ever created. I mean, NASA has used it to protect the Mars rovers from the freezing cold, and even to catch tiny particles of stardust flying faster than a bullet.
Okay, if you thought that was weird, hold on. Our last category is truly mind-bending. We're talking about metamaterials. With these, the amazing properties don't even come from the substance itself. They come entirely from a tiny man-made internal structure that's designed to literally bend the rules of physics.
Now, the big one everyone talks about is, of course, the invisibility cloak. And the idea is actually pretty simple, in theory. The goal isn't to make an object transparent. The goal is to guide light waves around the object, kind of like how water in a stream just flows around a rock.
If the light comes out the other side as if nothing was ever in its way, then to an observer, the object effectively becomes invisible.
Okay, so that leads to the question that I know is on your mind right now. If the science is real, then where's my invisibility cloak?
Well, it turns out being invisible is tricky. There are a few big hurdles. For one, the cloaks we can make now only work for one very specific wavelength, or color, of light at a time. So you could make a cloak for microwaves that would hide you from radar, but you'd still be perfectly visible to the human eye. Building these super precise structures on a large scale is also incredibly hard, and the tiniest little flaw can absorb some light and create a telltale shadow.
So, where does that leave us? How do we actually take these amazing lab creations and start building the world of tomorrow with them?
Let's bring it back to something practical. If graphene is so great, this unbreakable, transparent superconductor, why isn't your phone made entirely out of it? Or your car?
Well, the answer has to do with something engineers call the valley of death for new materials. It really comes down to three huge challenges. First, the cost is just way too high right now. Second, scaling up production from tiny lab flakes to giant industrial sheets is incredibly difficult. And third, quality control is a nightmare. It's one thing to make one perfect little piece, it's a whole other thing to mass produce it flawlessly and affordably.
And this brings us to the real takeaway here. The future isn't about making things out of pure graphene or pure aerogel. No, the future is composite. We probably won't have cars made of pure graphene, but we absolutely will. Have things like carbon fiber car parts that have a little bit of graphene mixed in, making them dramatically stronger and lighter than anything we have today. So these materials, they're literally the building blocks for a future we've only dreamed of. But they're also a massive set of puzzles waiting for a solution. And that really leaves us with one final question. Who are the engineers, the scientists, the creators who are going to solve these puzzles and actually build that world of tomorrow? The architecture is everything, and right now, the blueprint is still being written.